Welcome to another video on our YouTube channel, Functional Studies 101. So today we are going to be looking at a tutorial exercise on that was an exercise that was given to the civil engineering students in the University of Wales during their first semester examination. So the question says that we are asked to prove that cosine of x is strictly greater than 1 minus x squared divided by 2 for all values of x greater than 0. Okay, so if you are new to this channel, kindly hit the subscribe button and don't forget to turn on the notification bell so that whenever new contents are made available on this channel, you will not be left out. Once a video is published by the creator, you will not be left out. You'll be the first to be notified. So to get to me, you can request for my WhatsApp number or drop your WhatsApp number in the comment section so that you can also be added up into the group. I'll reply to all your comments. Now, if you don't know me, I am Engineer Tem presenting this script. Okay. Now, let's get started. It's a very simple exercise, but it looks frightful from the first sight of view because many students are very familiar with this expression for small angles of cosine where x is small. Now that x is large, that's moving away from 0. When they look at the equation now, it looks strange. So if this is your first time of coming across this question, this video is for you. Okay, stay back and follow the steps. So let's get started. Okay, the question says that we should show that cosine of x is strictly greater than 1 minus x squared divided by 2 for all values of x. The very first thing we are going to do is to move this term to the left hand side. When this term moves, right, all of this now will change sign, right? So everything will now be cos x minus all of this thing greater than 0. So we'll call this part that is left on the left hand side a function f of x defined by cos x minus 1 minus x squared divided by 2. Make sure you impose the brackets, that's the parenthesis. If not, you might easily make a mistake for sign a sign error here. That's you just take a negative and attach to the 1 here, which is not going to be correct. So we'll define this function. Okay, if we are able to prove that this function is greater than 0, because we have just called denote the left hand side to be what, f of x. So if you can prove that this expression, this function is greater than 0, it means we have established that cosine of x is strictly greater than 1 minus x squared divided by 2 for all values of x greater than 0. So now the very first thing we have to do is to rewrite this. We have to simplify this cosine. We know the double angle identity for cosine. Okay, like I said, we have to establish that f of s is greater than 0. Okay, since f of s is equals to this, and when we move this term this way, we are left with what? Greater than 0. 0 on the right hand side. So if we can establish this relation, then we are proving this the equation, the task is done. Now we have to recall the double angle identity for cosine. Cosine of 2x is the same as 1 minus 2 sine squared x, or you just write sine x all that squared, same thing. Okay, now from here, the reason why I want to use this identity so that this negative one, because when it's distributed, we have a certain negative one here, right? So we want to use the half angle identity for cos to replace cos x by its equivalent half angle identity. So It means that we know that cos x from here, cos x can be written as what? Cos 2 times x over 2, because the 2's can cancel and I'm left with x. So these two identities are still equal. From this stage, we will now apply the identity. My angle x is now x over 2. So anywhere I see x in this identity, I'll replace it by what? X over 2. I hope you're understanding. From here now, we'll have this will be equal to 1 minus 2 sine of what? X over 2. All that squared, everything is squared. We'll now replace this in our function. That's the expression for cos x. We'll replace it in this function. So f of s will now be 1 minus 2 sine x over 2, all that squared, minus, because we're distributing now the negative sign, you have minus 1. Then now, negative times negative, positive, positive x squared on 2. So you now see why we were using this identity. You could also use the other identities for cosine. That's 2 cos squared x minus 1. Okay, or use cos squared x minus sine squared x. Anyone will work, but use the one that will simplify the make work easy for you. From this stage, we'll now move to the next slide, and I'll copy this expression so that we simplify it together. Okay, so we have the expression in the previous slide that was given like that. You see negative 1 minus 1 is 0 now. So you are left with what? This term. We'll copy the positive term first. So x squared, f of s will be equal to s squared on 2, yes, minus 2 times sine of x on 2, all that squared. From this stage, this is a simplified version of f of x. We will now use a fact, okay? We'll use the fact that for every value of x which is positive, the sine of x over 2 is less than the angle. It is clear. This is a fact. You just need to use it. You quote it without giving any explanation. Take, for instance, the sine of 30 is 0.5 now. So you see that the sine of 30 is 0.5. That value is less than the angle itself. That's why we use this fact to solve this problem. The sine of any angle is always strictly less than the angle. Okay? Yes. So take note of this. The sine of any angle is strictly less than the angle when x is positive. Okay? It is only when x is approaching 0, that is x is small, that the sine of a certain angle is almost equal to the angle, but it is still less. So you see, in general, when x is positive, the sine of any angle is less than that angle. So from this identity, we now have to do what? We need sine of x onto all that square. So we square both sides, right? And squaring both sides will give us sine of x onto all squared less than x squared on 4, right? From here now, we notice that in the expression of f of x, we want to establish this expression that you are seeing here, this function. So we notice that there is a certain negative 2 multiplied to this this guy here. So you have to multiply that both sides of this equation by negative 2. Since we are multiplying by a negative quantity, the inequality sign reverses. Okay, so instead of having less than, the inequality sign now will reverse to what? Strictly greater than. So we'll multiply both sides by negative 2. So negative 2 will cancel here now, and you'll be left with just negative there, and then the 2 will cancel with this 4. 2 into 4 is 2 times now. Yes, so that's it. From here now, we are going to have my expression of f of s. I copy it again so that while I'm presenting, you just follow up directly. So from this expression of f of x, I'm working from the last step, right? All we now have to do is to add this term on both sides. I've added it on both sides. Since x is positive, and when you square any number, whether it's negative or positive, the answer is always positive. And since this quantity is positive, or even if it is negative, when you're adding or subtracting terms in an inequality, right, the inequality sign does not change. It is only when you multiply or divide by a negative quantity. From this stage, we notice that this is the function f of x, while this part now will now be what? Negative s squared on 2 plus s squared on 2. These are two terms which are identical, right? But they have opposite sign. They are equal in magnitude, they have opposite sign. Whenever you have two terms which are equal in magnitude and have opposite sign, and you add them together, the answer is always 0. So don't think twice here. This is automatically 0. And this left hand side is f of x. So we have that f of x is strictly greater than 0. Hence, we have established that cos of x is strictly greater than 1 minus s squared on 2 for all values of x greater than 0. Thank you for your time. That was a very simple question that was given for 5 marks. When you see questions like this, always try to attempt. There are various ways to approach this question. This is just one way, okay? This is just one way of solving the exercise. So I would like to thank you for your kind attention, and please make sure you give me a thumbs up if you enjoyed the video, and don't forget to subscribe. Most importantly, don't forget to subscribe. And when you watch a video, share it to your friends so that they can also benefit. Take note, discuss real analysis. You need to use the knowledge over and over and over, or even if you don't use it, for the sake of your schooling cycle. You cannot graduate without validating this course, real analysis 1, real analysis 2, as a civil engineering student. Also, this course is studied in other engineering fields. So even if you find that the knowledge, it will not help you at the moment, it will help you ahead, okay? Because most of the time now, when the lecturer is done teaching a course, maybe the next semester, they just assume that you people have understood everything in that course. So always try to understand, and don't think that once you have validated a course, that is the end of it. No, the knowledge, you have to use it. Keep applying it. You apply it. So don't think that you have validated a course, that's the end of it. It will hook you. It will hook you somewhere. So take your time. Follow the video. If you don't understand any part, make sure you hit me up in the comment section and I'll reply to you. See you guys in the next tutorial.